This is our contralateral hand with which we control the ipsilateral prosthetic hand. We have a total of 4 sensors on this, 3 linear potentiometers, and 1 accelerometer on the palm. Each linear potentiometer is attached to a piece of bite cable which runs through the top of each finger and is attached at the fingertips. The bite cable allows us to pull the linear potentiometer as we flex a finger and thus determine the flexion that we want in the fingers of our prosthetic hand. We chose to use bite cable so that as we extend our finger, this automatically pushes the potentiometer back into its resting position without the need for a return spring. The accelerometer on the palm of our hand is used to control the supination, pronation, and flexion and extension of our wrist, so we can tilt the hand either way or up and down, and this maps to the corresponding motion of our wrist on the prosthetic hand. We also have a vibrating motor in each of the fingertips, which are used for haptic feedback, and all of these are connected with these little connections so that we can easily remove them and use the hand or move the hand without being connected to the rest of our electronics. All of this was ran through this cable housing and into the main body of our prosthetic arm, where we house all of the electronics.
So this is our ipsilateral hand. It is made of PLA for the main body of the hand. The fingertips and the finger pads are made of TPU, which allows for soft grasping of objects. At the very tip of the fingertip are rubber pads, which hide force sensors, which allow for feedback in the contralateral hand. The fingers have 4 strings that allow for their flexion and extension. 2 are attached to the servo in a pulley motion, which allows for the flexion and extension, and 2 more are attached to the base, which allow for the kinematics of the hand, so they remain open or closed. We have 3 servos attached to the hand to allow for movement. 1 for the thumb, 1 for the index and middle finger, and 1 for the ring and pinky finger. At the base of the hand, we have a wrist, which allows for pronation and supination up to 180 degrees. It is held in place by a retainer ring and extends below the base with ball bearings to hold it laterally while allowing for free rotation. It is all mounted to an aluminum block that holds everything in place and ensures that it doesn't move. At the base, we have an area for the electronics to be held.
The wiring for the force resistors runs through the fingers, through each joint, and then into the palm. The wiring for all the servos runs through the palm as well, and all of this exits at the wrist. It then enters the braided sleeving, which runs through and enters our wrist housing right down here. This then goes over to our main control unit, where we have a board with everything soldered together, including a couple H-bridges and some voltage regulators to drop our voltage from 7.4 volts that the servos run on to 5 volts for our other components. This is housed in a PLA box which velcros down to the top of our Arduino housing. This allows it to rest in the middle when all the other wires run over the sides and into the slots. This entire apparatus can then slide right into the back of our wrist housing, and everything will come together like so. This is a demonstration of the autonomous feature in our hand, where we automatically stop the closure of our fingers when we come into contact with an object. This feature is not implemented on the index finger right now, but it is implemented on the middle finger for demonstration purposes. So as you can see, when the index finger is in contact with my finger, it will continue to try to close the hand when I move my finger. However, when the middle finger is in contact with my finger, now the hand will not attempt to close, as it knows that it is in contact with my finger. Okay, so this is now just a demo of our hand actually working and put together. You can see that as I rotate my contralateral hand, the wrist rotates accordingly. Additionally, I have full control over individual thumb, and then index and middle finger movement, as well as ring and pinky finger movement. So let's see if I can pick up any objects. Oh, and there's that haptic feedback. Oops. But when I did that, I felt my vibration in my thumb and my index fingers here because of the force sensors on the fingers. This is a pretty heavy object. Hey, there we go. Maybe I'll do some soldering.
For Dr. Gross Biomedical Mechatronics Final, I'm Jonathan Zimmerman,
I'm Chris Schmidl.
and we'll see you next time.